Hi, this is Chris Kanish, and this is CS44, Secure Web Application Development. Today, I'm going to be covering a little bit of a bonus lecture that I wasn't able to cover during class, but I wanted to make it available to everybody, so this is what we got. What we did have in class a couple days ago was an amazing lecture by my former student, Pete Snyder, who works at Brave Software. He talked a lot about the tracking ecosystem in general, and there's a little bit of gray area here in terms of what's good about tracking, what's bad about tracking, whether somebody intends to track, whether a user is aware of that tracking or not. But then what we're going to focus on today is something that's a little bit more clearly adversarial tracking. So just to refresh our terms, tracking is when you're linking activities of individuals across boundaries, whether it's from one site to another, one time to another, things along those lines, in ways that are not expected or desired. But what we're going to be talking about today are some very different forms of slightly more adversarial tracking. In general, going back to Pete's set of slides, he had these ideas of these questions of, is this tracking or is this not? So we could imagine that if I go to a certain website and then some time passes and I go back to that same website in the same browser later on, I don't expect that site to not be able to track me from day A to day B, whatever have you. However, what we could do is go to a website in our browser and then open up the clear browsing data dialog box that most browsers have, and I say, you know what, I want every piece of information, every piece of state about me and my interaction with this website to be blown away and never be referenced ever again. So you could imagine in that situation, if some site is still able to do that, that's what I would call a bit more adversarial tracking. Because in my personal opinion, when I actively try to make this website forget about me, if it says, no, I'm still gonna remember who you are, that's not cool. In addition, there's another class of tracking where we have site A that we're visiting, and then when I go to site B, it learns something about what I did on site A. Whether that's something like whether I visited or not, what my cookie is, anything along those lines. When we're going across these boundaries from one site to a completely different site, it's not in the public suffix list as the same thing. It's not the same origin, any of that information. This also, I would definitely consider tracking. We're going to talk about an attack called history sniffing. So history sniffing is a way for this completely different site to learn something about the fact that you have visited some other site in that same browser in a way that you probably don't expect to actually be possible. So let's go to some very, very basic HTML 101 type information. When we are creating text and we put a hyperlink on it, by default, when there's absolutely no styling whatsoever, the default style put in by the browser is gonna have links that I've never visited before ever in my life as blue with an underline, and links that I have visited are purple. We've all seen this many, many times, but probably without even thinking about it. Now, in JavaScript, there is this ability to introspect on a page and figure out what is the style that is getting applied to one specific character, one specific DOM node, whatever that is. And that allows the website to say, oh, I wrote some CSS, but I want to make sure that that's actually what it says it is. This is a capability that is in the browser. And you could imagine you put these two different ideas together, nothing about what these links are is tied to the internal site. If I am creating a website, I can link to anything in the rest of the World Wide Web. That's pretty much the idea. So I should be able to make a link to a completely different website from my own website. I should be able to run get computed style. And lo and behold, what I could probably do is put a link to Google, a link to LinkedIn, a link to uic.edu, any of those things in my own page using JavaScript, and then check, hey, is that link purple? Is that link blue? And that allows a website to do this history sniffing attack. And it was pretty nasty. This was about 12 years ago now, a little ways ago, but it was a very, very prevalent attack that lots of websites, including really, really big ones that we've all heard of, were very aggressively inserting DOM nodes with individual links to their competitors, or just every website in the entire world, checking to see what the color was, taking it out, putting another one in, taking it out, putting another one in, all that stuff to figure out where an individual user has gone. Thankfully, this has been fixed in browsers for over the past 10 years. by having the browser effectively lie to the JavaScript saying, you know what, you're going to ask me whether this is blue, ask me whether this is purple, based on whether it's been visited or not. I'm going to tell you it's blue every single time, no matter what. I'm not going to let the history influence what JavaScript shows to the user. But this ends up a little bit tricky. It's certainly not perfect for two reasons. One, this isn't the only way that a browser can introspect and check state across these boundaries. And number two is that just because you can't introspect in JavaScript doesn't mean you won't be able to do a social engineering attack. So one really cute way to circumvent the defense that was put in by the browser is to ask the user to click on things based on whether they are colored with a visited link or colored with a non-visited link. Now, blue and purple are the defaults, but you could just as easily say, oh, a white on white background is something that I haven't visited before, and a black on black background is something that I have visited before. And then you could create a fake CAPTCHA like the one in this example, and you ask, hey, I want you to click on every single one of these boxes based on whether you're a robot or not. So you're gonna lie to the user and you say, I'm gonna do some social engineering, I'm gonna tell you that I'm doing a CAPTCHA, but what I'm really doing is I'm asking you to click on a bunch of links that don't redirect the browser, but that send that information back to the server and say, hey, this person has visited Hacker News. Hey, this person has visited Google. Getting that human into the loop causes the browser's defense to break down, but this takes, a couple seconds per box, maybe half a second. What was found in that previous study, they were looking at history sniffing, so they could find hundreds of thousands of these could be checked per second on a given web page, and that would qualitatively change the game in terms of how effective history sniffing could be. Now, history sniffing is one mechanism. That fundamentally has to do with finding a side effect of some stored state. There's actually a lot of other explicit pieces of stored state that are stored in the browser, but the browser is this incredibly large, incredibly complicated piece of software. Thousands of different people are working on it at a given point in time. You could imagine that somebody's going to introduce a feature over here and over there where they're trying to do the isolation between different sites. They're not going to realize, oh, hey, I need to make sure that this is compartmentalized and not visible across these boundaries. So there's this concept of an ever cookie. Basically, in the way back, before everything just ran in the browser, we had these things called plugins. You needed a plugin to watch videos. You needed a plugin to look at Flash animations or play games. You needed a plugin to do all sorts of different things. And each of these individual plugins are just native code that has its own storage, that has its own execution model, that saves its own things on its own way. And what was found historically was, hey, if somebody is deleting their cookies, that doesn't delete the cookies that are stored in the Shockwave Flash storage. So this has gotten a lot better now that browsers have said no plugins, just do everything natively in the browser. The browser maintains complete control over what code is running in your device, and it can do the compartmentalization. But gigantic browsers, millions of lines of code, thousands of different developers adding and removing things on a daily basis, there are going to be places where this messes up. And so myself, along with some really hardworking PhD students and colleagues of mine, have a paper coming out next year in 2023 where we said, look, there are all these different features being added to the browser. What we want to do is come up with a comprehensive, systematic way for us to figure out, hey, is there information leaking from site A to site B using one of these new features? And we found a good handful's worth of different leakages from one site to another. And sometimes these are in really esoteric features that might only allow that leakage to happen over the course of minutes or hours, but these are still things that don't give you that hard guarantee of something that happens over here does not have any impact on something that happens over there. Isolation is incredibly important when we talk about security on the web in modern computing in general. Now, changing gears a little bit, we were talking about this stateful tracking, talking about surreptitious history sniffing or ever cookies or these extra, other kinds of cookies which are fundamentally storing state on your device. That is one way to store it, and then you come back and you retrieve it and you say, aha, this is the same thing that I stored earlier. I'm going to use this to figure out who this person is. Another way is without any state storage at all. Every person's individual device is going to have some fingerprint, if you will. This is a more passive form of tracking, and it's a little bit nastier here because it doesn't require any sort of information to be stored on the person's device. That information is already there. You just have to retrieve it and hope that that information is unique for that one individual, and then you can use that to make sure that, oh, this person that comes back later is the same person or is accessing this via the same device. So how does fingerprinting on the web work, right? Like a browser doesn't literally have a fingerprint, but what browsers have is a lot of properties that are unique based on customizations of the operating system, customizations of the browser itself, all these different things that cause that one browser to be a little bit different than every other one, even if you're deleting every single piece of saved information that is associated with a given website. So there's all these semi-identifiers that you're gonna get out of a device, and some of them, like the browser size, like the extra fonts, like what the list of installed plugins are, the color depth, the language of the user, the default language, things like that. Those are all things that can explicitly be read out as this is something that the web API gives you the ability to check the user's preferred language, the ability to check what fonts they have, the ability to check how big the browser screen is. And you can imagine that those things are just necessary to give somebody a good user experience. There's a few of these that are a little bit trickier, like the audio hardware and the video hardware, where different devices, because the way that the silicon has been created in a fabricator, are going to react in slightly different ways. Like one 2021 MacBook Pro and another 2021 MacBook Pro might not run exactly the same as each other. I'm not sure if the MacBook Pro has these problems. It probably doesn't, but in general, the hardware that's being used to listen to analog information like a microphone, the hardware that's being used to render things in a big pipeline on a very complicated GPU. Those are things that have slight artifacts that are possible just from the manufacturing differences. So these are things that where you could actually cause a standard set of pixels to be drawn with the GPU, and then pull those back out and say, hey, did they draw slightly differently in terms of timing? Did they draw slightly differently in terms of just the color of each individual pixel? Because that stuff is so complicated, and because the differences of drivers, the differences of versions of GPUs, all of that stuff is gonna have very, very subtle influences on what gets pulled out. Those are still able to be fingerprinted in some situations. So at the end of the day, what you're getting out of this is the ability to pull a little bit of information out, like a number of bits of identifier. But each one of these individual things doesn't just immediately give you enough information to say out of the 8 billion people in the world, out of the billions and billions of devices that have browsers on them, this is Chris's cell phone. This is Chris's laptop. But what you need to do is put a lot of this information together to really pare down the list of potential users that this could be reflecting. So you can imagine billions of people use browsers every single day. You are one person in the 5 billion people that are actively using the internet on a regular basis. All Firefox users could be some chunk of that, and it's very trivial to figure out based on, say, the user agent string. Oh, this is a Firefox user. Then there's people that are using Windows, and pulling out what operating system you're using is something that you can do via introspection to the browser's user agent string as well. There's which fonts you have available to you within that browser by default because you had installed them into your Windows install. There's whether or not you're sending the do not track header, which I turn on, which is a little bit weird, where it's so uncommon to turn the do not track header on because you manually have to turn it on, that it is actually very good information source for whether this is a specific user that I'm trying to remember or not. If only 100,000 people manually turn that on, you very, very quickly put yourself into that little bucket of 100,000 people, and this fingerprinting mechanism will try to figure out which person you are out of that 100,000 rather than worrying about which person you are out of that whole 5 billion. So when you look at the entirety of the intersection of all these different things, a little bit of information here, a little bit of information there, that very, very quickly brings you down to, oh, this is just one user out of the billions that I've seen have this same exact fingerprint based on the fact that they have all of these individual properties. So fingerprinting still needs some common value that's repeatable across different times, across different sessions. Very often fingerprinting goes to an individual device rather than an individual user. So that gives you an idea of, oh, this is a device that I'm tracking. I'm not tracking the individual, but nowadays devices are so often just personal individual use devices that they're not really that important of a difference. The values themselves can be unique, but remember, we're looking at an intersection of all these different values. Millions of people use Firefox, millions of people use Brave, millions of people use the do not track header, but if we pare it down to they use Brave and they have a 1024 by 7068 monitor and they have Wingdings installed and they're using English as their default font, then we're going to bring it down to a much smaller group of people. And one of the trickiest things that's really important here is that these values need to be consistent over time. Something like your browser size, that's going to change. That's going to change from day to day. You zoom in, you zoom out, you put two windows next to each other. All of a sudden the browser's screen size is not the same as it used to be. That causes these fingerprints to break. And so making robust fingerprints that can still identify a user even after they've changed a few of these properties is an important part of doing fingerprinting correctly. So the ways we can actually defend against this are making browsers look more similar. So just the low-hanging fruit here is don't have every single user agent string show exactly which subversion you have of your operating system, of your browser, of this, of that, yada, yada, yada. Though that's something that has been coming a long way in recent times. Blocking the people that are trying to do fingerprinting is certainly something that has been effective in this way. There's another way where we could say, look, we know that a certain amount of entropy, a certain amount of unique bits identifying you can be pulled out of reading the screen size, can be pulled out of reading the preferred language, can be pulled out of any of these different identifiers. What you could do as a browser is say, look, I'm going to let you pull a little bit because you might need it to show your website. I'm going to let you pull this because you might need it to actually make your website work. But I'm not going to let you pull every single one of these identifiers out because then I've learned enough to say uniquify you among 4 billion users or 8 billion users because I have so many different bits of uniquifying information about you specifically. And another thing, and this thing that I believe Brave does reasonably aggressively on some of these nastier fingerprinting mechanisms, is randomize the information. Just intentionally lie about this piece of information or that piece of information. In general, the web is pretty robust. It works well even if some of these pieces of information are delivered incorrectly, because a lot of the times the user-facing experience is not strongly predicated on receiving that specific piece of information. Like if you instruct your browser to lie about its size, sometimes things are not going to render correctly, but a lot of the times you're going to be able to get the value out of that site that you planned on getting. So that's basically everything there is about fingerprinting that I think is pretty important. The one final thought that I'm going to leave you with is definitely food for thought, where fingerprinting itself is a dual-use technology. It both has the ability to be used to track users against their will, to show them advertisements that they don't want to see, to keep track of them, to keep a big database of everywhere every person has been on the web without wondering about isolation or without caring about user consent. And that's nasty. That's something that I don't think we should have. There's a lot of good reasons why that shouldn't be happening. But fingerprinting can also be used in a security context where you say, oh, there's some bots that are being used to perpetrate fraud. We're trying to come up with lots of different users that create a free account and get the $10 bonus for just signing up or whatever have you. There's a lot of real good reasons that a security team that's doing defense would want to know, hey, I am not going to allow this user to keep making accounts over and over and over again, even if they have a lot of proxies and they make their source IP be very, very different. Even if they delete their cookies and they come back to my website again. I want to know who is trying to attack my website, even if they are trying to hide their identity and show up again as somebody else with a fake mustache or whatever have you. So it's really, really interesting to think about fingerprinting, not just from this privacy standpoint, but also where it gets a lot of extensive use on the security side. You'll probably see, if your browser has a fingerprinting blocker or fingerprinting tracker, you might see a little notification saying, oh, hey, I just blocked fingerprinting on this website. And I'll see that actually really, really often when I'm logging into PayPal, when I'm logging into my bank, when I'm logging into Instagram, things like that, where I'm like, well, it could be because they're trying to fingerprint me and track me everywhere they possibly can, but most of the places that this technology is being deployed nowadays, it's being deployed for this purpose, to be an actual security mechanism that will allow the defenders to keep those users who are coming back and attacking over and over and over again out. The big question then that I like to ask in this situation is that information only being used for that purpose? Or after the information has been collected because they need it to do anti-fraud, it's sitting right there, why don't they let the analytics team also take a look at it and figure out which users are coming back to the website? That's something that we can't have a really clear idea of from the outside, and it's part of what makes security and privacy on the web such an interesting place to work. So that's what I've got for you on fingerprinting today. Thanks so much for watching, and I'll see you next time.